Hello students, so welcome to the class. Today we will see the NEET PYQs for the chapter 1, some basic concepts of chemistry. Okay, so let us see the PYQs of this NEET thing. Disclaimer, the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is experimental. Your first question is, what will be the molarity of a solution which contains 5.85 gram of NaCl per 500 ml? So, your time to solve this question starts now. So, it's a very simple question. You just have to calculate the molarity. Okay. So, let us see the correct answer. Correct answer will be C, 0.2 mole per liter. Now, how we'll solve it? What is the formula for molarity? It is calculated by using the formula which is given by number of moles divided by volume of solution in liter. So this is the formula, but the volume of this given solution is given in milliliter. So we have to divide this volume by 1000 to convert it into liter. How do we calculate the number of moles of the NaCl? So it will be simply given mass divided by the molar mass. If you put all the values, you will get 0. mole per liter as the correct answer. Our next question is, if 500 ml of 5 molar solution is diluted to 1500 ml, then what will be the molarity of the solution obtained? So this was asked in the NEET 2023. You have 4 options: 1.5, 1.66 m, 0.017 m and 1.59 m. Your time to solve this question starts now. In this question, you just have to use the formula M1V1 equals to M2V2. We have already seen that formula in the previous class. Just put all the values and calculate the value of molarity. So let's see what is the correct answer. So we have to calculate the molarity upon the dilution of this 500 ml solution to 1500 ml. The correct answer will be B, which is 1.66 m. Yes, the correct answer will be. How we will solve it? We know that for dilution, we have a general formula. We have already seen this calculational trick, which is M1V1 equals to M2V2, where M1V1 is before dilution and M2V2 is after dilution. So anyone has any doubt in this question? How I am using this formula? Yes, Naman. So are you asking that how do we obtain this formula? Do you need the process of obtaining this formula? Okay, let's see how we can do this. So just take the case of dilution. Suppose the question is asked that initially we have 500 ml of 5 molar solution. So we have 500 ml and its molarity is 5 molar. Okay. Now what are we doing? We are converting this 500 ml to 1500 ml. Now remember students, whenever we do the dilution, okay, so this is after dilution. So what we do in the dilution process, so listen very carefully. So what we do in the dilution process, we keep the number of moles of solute constant, and we keep on adding solvent on it so that the solution can become less concentrated. You got my point? Again, I am repeating it. So we are not, by dilution, we do not change the number of moles of this, say, given solute. We only increase the solvent. So here we have 1500 ml, not gram. Is it clear to you? Do you understand what is dilution? Okay. So what are we doing? Suppose we have a solution which has 500 ml of 5 molar solution. Okay. Now in the dilution process, we only add solvent. Okay, we keep on adding solvent until its volume becomes 1500 ml. Now in this process, there is no addition of solute. No addition of solute. We are only making the solution less concentrated by adding the solvent. Okay, clear? Now, how do we calculate the number of moles for the initial solution? To do that, we will simply use the formula of molarity. So, formula of molarity is number of moles divided by, so I am erasing this thing, it is number of moles divided by the volume. So, this is the simple formula. Then how do we calculate the number of moles? We will simply take number of moles is equals to m into v. Isn't it? Is this point clear? Okay. Now suppose we are taking for the initial condition. So we are telling this as m1 v1. Okay. We are telling it as m1 v1. Got it? So this is suppose m1. This is v1. Now after, so let me write it v1. This will be v1. This will be m1. Okay. Now after dilution, we have a new volume plus we have a new concentration about which we are unaware. We have to calculate it. So let us assume that molarity is m2. Yes, Gaurangi, you are telling it right. So if we keep on increasing more and more water, we are decreasing the concentration. So it's very simple to understand it. Take the example of color. So when you play Holi, you put a pouch of color in a bucket. Now you put that same bucket of water into a tank and now keep adding water. What will happen? It will become less concentrated, and the signal of it is the lower intensity of color in the given solution. Got it? So this is the first condition. This is the second condition. We have m1 v1 and we have after dilution a new volume and a new molarity. Till this point, anyone has any doubt? Now if I ask you that if this is the number of moles before dilution, okay, if this is the number of moles, I can say it is before dilution. Then what is the number of moles after dilution? Number of moles after dilution, if V2 and M2 are the molarity and molarity, yes, very good. So number of moles after dilution will be M2V2. So anyone has any doubt in these two terms, M1V1 and M2V2? Yes, Riya, you are telling it right. Now since the number of moles is equal, therefore we can say that M1V1 equals to M2V2. So it's a very basic, you can say, derivation. I guess no one has any problem with this derivation now. It's very clear. So what I am saying is the concentration is decreasing after dilution, but the number of moles of solute is not changing, and that is the criteria we are picking up to equate both of these terms. Yes, V1 will become V2 and M1. Okay, got it. So Priyanshu is saying that concentration of solution decreases when the solution volume increases. Yes, it is correct. So can I now use this formula? I think you must have understood this. So let us get back to the question. Is it clear to all of you? So anyone has any doubt, they can ask it now. I guess it is crystal clear. Until and unless you are unaware about the formula, you won't face any difficulty to understand this. So let us get back to the thing which we were discussing. Now we have the initial molarity, initial molarity and initial volume and the final volume. But we don't have the final molarity. Just put all of these values. If you put it, we can calculate the M2 from here. Just cross multiply this thing and you will get it as 1.66 M. So I guess it is very clear to you once you are known about this formula. Now moving on to the next question. So this was asked in the NEET 2018 and a similar question, I would not say similar one, but I would say similar type of question, I can sell it, a similar type of question was asked in the 2024, not exact one, but a similar one. So you have to calculate the number of atoms present in 1 mole of an element. Okay, so we have different grams of the element. We have 4 grams of helium, 4 grams of sodium, 0.40 gram of calcium and 12 grams of helium. You have to calculate which has the greatest number of atoms. Your time to solve this question starts now. So the clue for this question is simply calculate the number of moles and then you are good to go with the calculation, rest of the calculation. So let us move to the question. So what was given? We were given 4 different masses of 4 different species, and in each of that we have to calculate the number of atoms and see that which one has the greatest number of atoms. So the correct answer is D, which is 12 gram of helium. I told you the clue for this would be the calculation of number of moles. Let us see how. So for the first species, we have 4 gram helium. Now what is the molar mass of helium? It is 4 gram per mole. Then what will be the number of moles? Given mass by molar mass. So given mass is 4 gram and molar mass is 4 gram per mole. Therefore, we have 1 mole of the helium gas. Now how do we calculate the number of atom? It's very simple. Just multiply your number of moles with the Na. What about the next one? Next one we have 4 grams of sodium. Now what is the molar mass of sodium? It is 23 gram per mole. And how many grams is given? 46 gram. Again given mass by molar mass. That will give you 2 mole. Now for 2 moles, the number of atom will be simply 2 into Na. Moving on to the fourth species. We have 0.40 gram of calcium. Again calculate the number of moles, which is 0.01. Multiply it by the number of atoms. You will get it as your number of atoms in the 0.40 gram of calcium. Now last question. We have last option. We have 12 gram of helium. Again we know that the number of moles formula is given mass by molar mass. So 12 by 4 will give you 3 mole, which will be number of atoms is equals to 3 into 6.022 into 10 to the power 23. We can see and say it very clearly that 12 gram of helium has the largest number of atoms, as it has 3 multiplied by the Avogadro constant, whereas other have 1, 2 and 0.01 as the factor multiplied by the Avogadro constant. Next question. If the concentration of glucose is 0.9 gram per liter. Now what does this mean? It's important to understand this thing. Once you get this, you can easily solve the question. So the question is asked that what will be the molarity of the glucose in blood. We have 4 different options. This was asked in the NEET 2023. Your time to solve this question starts now. Let us try to understand the question. It was given in the question that the concentration of glucose is 0.9 gram per liter. So what does it mean? It means that there is 0.9 gram of glucose that is present in per liter of the solution. So to understand this concentration term, so you must have not seen this concentration term earlier. To understand this, you have to just understand the unit. Unit is important here. So the unit is clearly saying that the amount of glucose which is dissolved in 1 liter of the solution is 0.9 gram. Therefore, it is written as 0.9 gram per liter. Now, if you take this thing, then you will get your answer as 0.005 m, which is option number C. Let us see the solution for it. So we can also say that if 0.9 gram per liter is the concentration, that means 1000 ml or 1 liter of the solution contains 0.9 gram of glucose. What is the molecular mass of glucose? It is 180 U, unified mass. You can try and calculate it. Then how do we calculate the number of moles? It is very simple. Given mass by the molar mass. So you can take this molecular mass as molar mass by converting the unit to gram per mole from unified mass. So that will give you 5 into 10 to the power minus 3 mole. It's very easy to solve this question now. We are already being told that 0.9 gram is in 1 liter. That means 5 into 10 to the power minus 3 mole of glucose is in 1 liter. And this is simply the molarity of the given solution. So anyone has any doubt in this question? They can ask. Is it clear to all of you? So what is your doubt? So I'm trying to solve as much question possible which is related to this chapter so that you can get a clear picture of this. So what I'm saying is that about the last line, okay? So let us see what is the last line. So what we know that 0.9 gram is in 1 liter, right? Or we can also say 5 into 10 to the power minus 3 mole is in 1 liter, which is being calculated here. Now what is the definition of molarity? It is number of moles per liter of solution. So this is the definition. You have to calculate this, but I guess we have already calculated this here. Okay. Therefore, we can say that this here is simply the molarity. You can also calculate it using the formula. So that would be 5 into 10 to the power minus 3 mole divided by the volume of solution, which is 1 liter. Therefore, you will get 5 into 10 to the power minus 3, or you can also say it as 0.05 capital M. Okay. Now moving on to the next question. So here is the next question. Your time to solve this question starts now. Let us see what is this question. So this was asked in the NEET 2024, again in the previous year. The question is saying to to calculate the molarity if we are dissolving 18.25 grams of HCl in 500 gram of water. The correct answer will be D, which is 1 molar. So it's very important. I have written it as molal. Okay. So this is not your meter, it is your molality, because molality is represented by small m. How we will solve it? It's very simple. A easy question to solve. You know the formula, mole of solute divided by the mass of solvent in kg. We already know that the molecular weight of HCl is 36.5 gram. So we can calculate the number of moles of HCl from here. It will be 18.25 by 36.5. That will be 0.5. So this is the number of moles of HCl. How do we calculate the molality? So to calculate molality, we will divide moles of solute, which is 0.5, by the mass of solvent in kg. So 500 grams. To convert it into kg, we have to multiply the thing by 1000, which will give you 1 molar as the correct answer. Moving on to the next question. So here's a question. We have to calculate the mass percent. Your time to solve this question starts now. I guess it's a very easy one. I would expect answer in the comment section. What you have to do in it? We have to simply calculate the mass percent of carbon in carbon dioxide, whose formula is CO2. The correct answer will be D, 27.27%. How do we calculate it? So first of all, the molecular mass of carbon dioxide is 44 grams. Now, to calculate the carbon percentage, we must know that in 44 gram of this carbon dioxide, we have 12 grams of atoms of the carbon, right? Then what is the percentage of carbon dioxide? It will be the total mass of the carbon dioxide of 1 mole of carbon dioxide and the mass of carbon atom in 1 mole of carbon dioxide, which is 12. Just divide both of this, multiply it by 100, you will get it as 27.27%. Therefore, the mass percentage of carbon dioxide is 27.27%. Our next question. The empirical formula and the molecular formula and the molecular mass of a compound is given as CH2O and 180 gram. What will be the molecular formula of the compound? So you have 4 options: A, C9H18O9, B, CH2O, C, C6H12O6 and D, C2H4O2. Your time to solve this question starts now. It's very simple. Just calculate the empirical formula mass, calculate the n factor and multiply it with the empirical formula. So most of you are giving answer as C6H12O6. Let us see. What are the things that are given? Empirical formula is given and the molar mass is given. If you use this, you will get the correct answer is C, which is C6H12O6. Then how will solve it? Our empirical formula is CH2O. If you calculate using this empirical formula, you will get the empirical formula mass as 30U. And what is the molecular mass? It is 180U or 180 gram per mole. So this is molar mass and this is your molecular mass. Both are same, you know it. You just have to change the unit. If you divide both of this, so 180 by 30 will give you 6 as the factor, multiplying factor. Just multiply it throughout the given formula. You will get your molecular mass from here, which is C6H12O6. Now moving on to the next question. This was again asked in the NEET 2024. You have to calculate the highest number of helium atom in the 4 compound. So we have different options. Your time to solve this question starts now. Let us see what is the correct answer. The correct answer will be A, which is 4 mole of helium. How will solve it? For the first option, the number of mole is 4 mole. Therefore, the number of atoms will be 4 multiplied by the Na, your Avogadro constant. What about the second one? If we take 4U, that means we have 1 helium atom, because 1 helium atom has a mass of 4U. So therefore, the number of atom is 1. Then what about 4 gram? So in 4 gram of helium atom, we will have 1 mole. Simple formula, given mass by the molar mass, so that will give you 1 mole. Now what is the number of atom? So that would be 6.022 into 10 to the power 23 atoms. Last option, it is 2.271098 liter. So we know that 1 mole of a gas at STP has 22.4 liters. Therefore, in 2.271098 liter, there will be 2.271098 by 22.4 moles. That is 0.1014 moles. Now, what is the number of atoms? It will be 0.104 multiplied by the Na. That will give you 6.11 into 10 to the power 22 atoms. So, anyone has any doubt in this options? Okay. So, I have a thing to tell you. So just try to understand this concept. Okay. So, we know that 22.4 liter has 1 mole. Therefore, 1 liter will have 1 by 22.4. So, it's easy to understand. I'm just making a revision of it. Therefore, 2.271098 will have 2.271098 by 22.4 mole. So this is the way you solve it, right? Yes, molar mass of helium is 4 gram. Got it. So again, I am repeating it. 22.4 liter means 1 mole at STP, right? Or we can say that in 1 liter, there will be 22.4 mole at STP. But in how many liter we have to calculate? We have to calculate it in 22.27. So we simply multiply 1 by 22.4 into 2.271908. Isn't it? Is it clear to you? How are we getting the number of moles from here? Harsi Raman Kaur, anyone has any doubt? You get it, right? Sir, okay. So today we will see the eudometry also, as we have time left with us. Yes. Now there is a thing I want to tell you. If you look at the NCERT, you will get the volume of 1 mole as 22.4 liter. Okay, so this is the thing. Now, if you search the internet, you will get it as 22.7 liter. So this is the new accepted one, right? This is the new accepted one. Got it? And this is the old one. But since your NCERT is using this 22.4 liter, we will use it so. So there is a small change in it. So instead of using 1 kilopascal, so earlier we were taking it as 1.01325, but in the latest calculation we are rounding off this thing to 1. So this is the reason we are getting the difference. No, it is not of STP and NTP, of course. You can go and calculate it for NTP. You will get a completely different value. You won't get this 22.4 and 22.7. Okay. So this is just an approximation. Got it? But you don't have to think much about this. Just take this value as it is valid in the NCERT and you can do your calculations. Is it clear to all of you? Now, again a question from NEET 2024. There is a compound X which contains 32% A, 20% B and the remaining percentage C. So 100% is the total one. You can simply calculate the value of the percentage of C by subtracting it from the 100. The atomic mass of A is given, B is given, C is given. You have to say the empirical formula of X. Your time to solve this question starts now. I guess it's a very easy question. Just convert the percentage into gram divided by the molar mass, get the number of moles and you will get the empirical formula. So let's see how we can solve it. So percentage of A and B is given. You have to first calculate the percentage of C. If you follow all of this, you will get your answer as ABC3, which is option number B. How we'll solve it? So if we take 100 gram of this compound, we will have 32 grams of A because 32% is A. We will have 20% of B, which is 20 gram, and 48% of C, which is the remaining percentage. So simply convert this thing into gram. That is the basic idea behind it. Then calculate the number of moles. Use your formula, given mass by molar mass. So molar mass of each of this is given. You will get it as 0.5, 0.5 and 1.5. Now out of these three, 0.5 is the smallest one. Okay, 0.5 is the smallest one. So divide each of this by 0.5. You will get it as 1, 1 and 3. So this will be 1, this will be 1 and this will be 3. Therefore, the empirical formula will be ABC3. Is it clear to all of you? Anyone has an issue? It's very simple, I guess. We have already solved this type of question multiple times. So one student is raising hand. I guess it is clear to all of you. So can we move to the eudometry now? Okay, so just wait for a while. I will get back with the eudometry thing, so which we have left in the previous class. Okay, so let us get back with this eudometry. So first of all, what is eudometry? You must have seen multiple times a question like this much carbon, hydrocarbon is burnt, and you have to calculate the molecular formula or the empirical formula for the given compound. Okay, so that is a process in which we use the combustion of your hydrocarbon to get the molecular formula of the given compound through the gas analysis. Now this definition may look absurd to you, but when you will get to the question, okay, so let us start this. So the basic idea is you have to know the formula of the hydrocarbon. Okay, you have to know the formula of the hydrocarbon with the help of gas analysis. What? With the help of gas analysis. Now this thing may sound absurd to you, but once you get along with the way of solving the question, you will know the basic idea behind this eudometry. But before moving on to that, you must know this formula. So this is a general equation for the combustion of any hydrocarbon. Now there is a one little change in here. So here it will be Y by 4. Okay, it will be simply Y by 4. Got it? So let us see how to understand this eudometry with the help of questions. Now there are some basic assumptions which is related to eudometry calculation. The first is you must know the Lusak's law of the combining volume. Okay. So if anyone has any issue in this topic, just wait for a while. Whenever we will move to this say question part, you will understand. Okay. So the important part is that you must know how to solve the question. And I guess at the end of this lecture, you will be able to do it. So for that, two things you must know. So that is for sure. You must know the Lusek's law of combining volume. If you don't know, let's assume that you know the at least the idea behind it. If you don't know the definition, you know the idea behind it. So you can look at this equation and get it that your volume which is combining, they combine it in a simple ratio. Second thing, you must know the Avogadro law, that at equal temperature and pressure, the number of moles is equal, or the number of volume molecule is equal in a equal volume. Then the third thing, which is adsorbent and the gases which are adsorbed. So if you have NaOH and KOH solution, it will adsorb CO2 and SO2. Similarly, H2O is absorbing the Cl2, and many other gases have different adsorbent. But our focus would be on the NaOH and KOH solution. What is the experimental setup for it? So there is a gas burette, which is this. Now it's very simple. After the combustion, the gases which are released, they are being adsorbed in this adsorbent, and rest of this is collected here. So this is a part of NCERT, not wholly from NCERT. There is a bigger picture behind it. So students face difficulty in solving this type of question. If you are able to understand the basics, you can do it. But still, due to the complexity of the question, in case of eudometry, there may be some difficulty. So let us move to the question as quickly as possible to remove this, say, disparity in the understanding. So there are some important points which must be considered. First of all, reaction always occur at the room temperature, and H2O is the liquid and N2 is inert. As I said you, so our only agenda in this eudometry method is to determine the molecular formula of the hydrocarbon using the eudometry. Now listen here. From here, just listen carefully. 3 steps are there to solve this type of question. First thing, so there must be combustion of a given compound. You must know the balanced chemical equation for the combustion, and most of the time you will get the combustion of the hydrocarbon. Now I have already make you see the general equation. I will make you see it again. Second thing, write the volume of the component before the reaction, whatever be the volume of the component. And third thing, write the volume of the gas after the reaction using Avogadro's law. Now try to understand this chart. Okay, try to understand this chart. So this was the step 1. We have written the combustion of the hydrocarbon. Okay, any hydrocarbon you take, any hydrocarbon, alkane, alkene, alkyne. So any hydrocarbon you take, you will get the same equation for the combustion, which will be according to this. So if X is the number of carbon in the hydrocarbon and Y is the number of hydrogen, then you will simply get this thing. In the starting of the reaction, you will have only hydrocarbon present and oxygen present. After the reaction, after the complete combustion of the hydrocarbon, there will be no hydrocarbon left in the reaction mixture. Got it? Now, what we know? We know that 1 volume of hydrocarbon reacts with how much? V volume of the O2. Got it? So I guess if you are facing difficulty, we will see the question. Just remember this, just try to remember this thing. Okay. Just try to remember this table. It's very easy to understand it. So just try to remember it. It says volume of hydrocarbon, volume of oxygen. Keep it here 0. Since water is not a gas, we will not take its volume. Then after the complete combustion, it will be 0 here. Some amount of oxygen will be used in the combustion. Therefore, we are subtracting that amount. So this is volume of hydrocarbon again, and we will get X volume of the hydrocarbon. What is this Y by 2? So this Y by 2 is the amount of water that is formed. But since this is water and it is liquid in state, we are not considering its volume. So just tell me, anyone has any doubt with this table? Are you able to understand this table? It's very simple. Just try to memorize it. I have tried to put the complexity of the question simply in this table. So again, we will see the question to understand it in a much better way. Remember one thing, that this CO2 that is being emitted in the product, it can be absorbed by the NaOH and KOH. We have seen it in the previous slide. If you don't remember it, you can see it from here also. Remember that if you are introducing potassium hydroxide and sodium hydroxide in the solution, then it will absorb this CO2. Now, this is your question time. If you are able to solve this question and you don't understand the theory, you don't have to worry about it. Just try to focus on this question now. First thing, what is given? There is a gaseous hydrocarbon. Okay, there is a gaseous hydrocarbon that requires 6 times its volume of O2. Okay, 6 times of its volume of O2 for complete oxidation or for complete combustion. Now, we have to see, we are seeing that after this reaction, it produces 4 times its volume of CO2. Then what is its formula? How will solve it? First thing, we have to use the methods one by one. So this is a hydrocarbon. We know the combustion equation. Write it down. What is the combustion equation? Suppose we are considering that our hydrocarbon is again CXHY. Then this will be the combustion equation. Okay, this will be the combustion equation. So this is our first step. We have written the combustion equation. Now what was the second step? Second step was to write the volume of each of this. But do we have the volume? Yes, it is given. 6 times its own volume and 4 times the CO2 is produced. So how do we write the component volume? Very simple. First, let us assume that VHC is the volume of the hydrocarbon, VO2 is the volume of the oxygen, which is required for combustion. Okay, which is required for combustion. Now, according to the problem, it is given in the question that the volume of oxygen is 6 times the hydrocarbon. Is it clear? The first equation is clear. How I have written it? It is again given in the question. So VHC is simply the volume of the hydrocarbon. Now it is given in the question that the hydrocarbon has 6 times its own volume. So it requires 6 times its own volume for the complete combustion of O2. Now what are we doing? We are taking the exact amount of O2 which is required for the complete combustion of hydrocarbon. Okay. So can we say that the volume of O2 will be 6 times the volume of hydrocarbon if we are taking the exact amount? So I think many of you would be facing difficulty. So it's a difficult one to handle. So we are using VHC because you have seen, so it's simply a notation, nothing to worry about it. So it is simply a notation for the volume of the hydrocarbon. So this was the first information that was given in the question. Okay, this was the first information. Now, what was the second information? It says that the volume of carbon dioxide that is produced is 4 times the volume of hydrocarbon. So these are the two things that are given in the question. So anyone is facing difficulty in this till now? So I'm just writing what is given in the question. Now moving on to the last step. What was the last step? It was to write the table. So let us write the table accordingly. So this was the step 1. This is the step 2. Initially before combustion we have 0 moles of carbon dioxide and no water is present. After complete combustion, hydrocarbon is used completely, and since we have taken the exact amount of oxygen which is required for the complete combustion of the hydrocarbon, what we can say? We can say that the volume of carbon dioxide is given as 4 times the volume of hydrocarbon. It is there given in the question. Now, what is the volume of carbon dioxide? It is XVHC. What is the volume of carbon dioxide? It is XVHC. And it was also seen in the equation 1 that volume of carbon dioxide is 4 times the volume of hydrocarbon. Now equate both of this. X times the volume of hydrocarbon and 4 times the volume of hydrocarbon, which will give the value of X as 4. Is it clear to all of you? Any doubt? So in the previous equation 1, we have taken this thing. It was given in the question as well. And from the table, which we have already seen, I have told you to remember it, that X moles of this will be produced. So that would clearly say that X is equals to 4. A very simple, I would say, calibration. Now next what we will do? Again, let us see the table. So this was the table. We have calculated the value of X. Now we are interested in the value of Y. Now we know that the volume of oxygen is 6 times the volume of hydrocarbon. It's there given in the question. But we also know that this whole thing will be equals to 0. Why it is equals to 0? Because we have taken the exact amount of oxygen which is required for complete combustion, because we have taken the volume of oxygen as 6 times the hydrocarbon, which is the required amount. Therefore, this whole value will be 0 because it is indicating the amount of remaining oxygen. Can't we say that? Now, if it is so, then next what we can say? If we equate it with 0, then what we can say? We can say that volume of oxygen is equals to 6 times the volume of hydrocarbon is equals to 4 plus Y by 4 of hydrocarbon. So from the previous equation I am writing it. I am writing from the previous equation where we have seen that volume of oxygen minus X plus Y by 4 of volume of hydrocarbon is equals to 0. Therefore volume of oxygen is equals to this much. Got it? Now we know the value of X. Just put it here and VHC and VHC will get cancelled out. Therefore Y is equals to 8. Therefore the value of X and Y is 4 and 8. Hence the formula will be C4H8. Now let me try to summarize this thing. What was the summary? It was given in the question that there is a hydrocarbon, say it is VHC. Now this hydrocarbons require 6 times its volume of oxygen for complete combustion. So the volume of oxygen is 6 times. And after combustion, the volume of carbon dioxide it produces is 4 times the volume of the hydrocarbon. Okay. Now what volume of oxygen we have taken? The exact amount which is required for combustion. Exact amount which is required for combustion. If it is so, then what is the remaining volume of O2? If I write it as the remaining one. What? The remaining one. Then we can see from the table that it was VO2 minus X by Y of 4 of VHC. So this was the remaining one. And we have seen that this was equals to 0. Therefore, can't we say that VO2 is equals to X by Y 4 of VHC and X value is calculated as 4. Therefore, we have taken this equation. I guess it is clear to all of you. So this is not present in the NCERT. There is some part of it which is in the Avogadro law and the Lusek's law. So if you are having confusion, we can discuss this later if we have time in any of the topic again. So this was all for today's class. Thank you.